Hello, everyone. Welcome to Developer Productivity Engineering Lowdown. I'm your host, Ruse, and we got Justin from Gradle here as well. Thanks for joining. A quick intro about what this event is about and why we're here. My employer, Gradle, right, sponsors this event, and we're doing this mostly to bring attention to developer productivity engineering and share stories from some of our partners and friends who do this really well, and to get you inspired and get you to really think about what's possible and what's out there. So we're very excited about kind of today's event. You have some QR codes here flying around. What are these things about? Well, we have a developer productivity engineering book written by the Gradle team. It's build tool agnostic, though it's written by the Gradle team and whatnot. As I said, our mission is to help you and get you to improve developer productivity engineering and developer experience. There's a workshop in there. There's I already mentioned the book. There's a build scan link, and they're all cool free stuff to help you get excited and try some of this stuff out. Very excited about today, right? We have Gautam and Ty, two old folks that I've known in the industry for a long time here. Justin from Gradle. It's interesting. I met Gautam, actually. Well, I met Ty first. I should talk about that. I met Ty long time, 2013, when I just joined Gradle. Ty was working at Evernote, and they at Google I/O they announced Gradle is the official build tool of Android, and Ty's like, hey, why don't you guys come over and tell us what this Gradle thing is all about, right? And so that's where Ty and I met. I met Gautam a few years later, where I said, Ty, hey, come on over to the Gradle Summit. We're organizing the Gradle Summit and talk about Gradle builds and tests. He's like, I have this gentleman you got to meet. And that's where he brought Gautam over, and he showed us all his build time charts and graphs and whatnot. And the rest is kind of history. Gautam, do you want to quickly kind of introduce yourself and talk about what you work on?
Sure. Thanks, Bruce. Hey, everyone. My name is Gautam. I am the tech lead for the Java developer experience team at Uber. My team is really focused on making sure developers are being productive in their day-to-day, are able to get their job done with the least friction. So this can encompass tools like the build system, the IDEs, the CI and CD systems, and anything generally to make sure they're being productive. And I've been more focused on the Java side, but also worked on the mobile side of things before this.
Awesome. Thanks for sharing. Ty, how about you introduce yourself?
Sure. Thanks, Bruce. I'm Ty Smith. I'm kind of Gautam's counterpart in many ways. I tech lead our Android Foundations and developer experience teams. So we focus on making the libraries and frameworks and build plugins and IDE experiences and everything else to help mobile developers at Uber be as productive as possible.
Perfect. Great. Thanks for that intro. All right, so let's get going into the topics, right? The first agenda item, right? We always want to know, like, hey, how is your developer productivity and developer experience teams structured and whatnot? And I don't know who wants to kind of go first. And I think you guys even have a slide on this as well.
I think I can take this one. So Uber's a pretty large company. We have 4,000 plus engineers that we need to support to be productive. Supporting that kind of scale takes a lot of focus on consistency and investment in the tooling. So Uber typically organizes into two different types of teams. We have our feature teams, which are working on end customer facing products like the rider app or the driver app or Uber Eats, things that the customers of the company see. And then we have platform teams that focus on internal tooling and libraries and infrastructure that's needed to kind of power all of the Uber end customers. And so our organization, developer platform, has a little under 200 people, and we're entirely focused on building out kind of the tools to help developers be productive in a consistent way. We have frameworks teams which are working on libraries to standardize how people are doing stuff, and we have the developer experience teams that are focused on build and IDE and CI CD, all of that sort of stuff. And then we have some hybrid teams as well working on things like code review systems and kind of other developer focused tools that don't fall into one of our traditional stacks of the development process.
That's huge, right? 150 folks supporting 4,000 engineers across Uber, right? How do you balance building product versus support and all this? And because you said you have folks that even potentially move around depending on what you're delivering.
Absolutely. I think all of the teams struggle to find a balance and how much, how to support versus how to kind of build out what the future products look like. And so typically there's a lot of support structure that teams put into place. We put in tools like dedicated Slack channels, internal Stack Overflow instance, office hours for engineers to come to, building up internal community or brand ambassadors for specific products so that we can start to spin up folks outside of our immediate org as helpers in the community, and then we try to balance that with a properly staffed leveraged platform team that has the headspace to kind of build out some of these big future looking projects. A lot of our projects have a 6-month or 1-year roadmap. There's not a lot of low-hanging fruit in developer productivity engineering once you've scaled the company to this size. So a lot of those projects are pretty massive, and we have to kind of staff teams around those to build some of that stuff. And it's really carving out the space so some of the teams can work on the long-term bets while we keep the feature developers productive in the short term with the proper support and other things that they might need.
Awesome. And to tell us a little bit more about this scale here, and that's a good lead way also to the next topic of, the tooling stack, right? Just in general, development stack, software stack, programming languages and whatnot.
Definitely. Maybe I can take this one. So we actually have a pretty interesting structure to Uber. Even though there's a lot of engineers, I think Ty mentioned we have 4,000 engineers. Uber is kind of unique in that we are also very operationally heavy. So there's a whole set of folks that we also support, all sort of engineering as well through other kind of projects. But in terms of just engineering scale, we have thousands of microservices, about 4,000 engineers, hundreds of thousands of deployments happening per month. This is purely on the backend side, lots of config changes. There's about some tens of mobile apps, but the complexity of these apps are very different than other normal apps that you would see. There's a lot of features that go into there. There's hundreds of teams that actually contribute to these mobile apps. So they are very complex, even though there's very few of them. Interestingly, actually, we only have 7 programming languages we support, even though there is so much code. There's hundreds of millions of code. We mostly program in Monorepos, which I think we will cover slightly later. And we process about tens of thousands of commits a month. And at this scale, some of the tooling that we build, I think, as I mentioned, that we build today may not actually work 2 to 3 years down the line. So we actually have to constantly keep innovating to anticipate what's the scale that we will be dealing with, maybe a couple of years down the line, and kind of start building systems for those ahead of time. Right. So, and if you want to talk about the development stack of things, there is a pretty good overview of our stack at a high level. So we have mainly 7 programming languages that kind of loosely translates to the platforms we support on mobile for iOS and Android. On the back end, we have mostly Go and Java. And each of these and we also have the web front end, which is on JavaScript. And each of these major platforms live in their own monorepo. And each of these monorepos are staffed by their own kind of centralized teams. I mentioned about frameworks as well as developer tooling. And focuses for those teams are usually to make sure the developers in those platforms are being productive. Right? So the centralized teams are what actually do all that support work, but also make sure we are adhering to things like standardization to make sure we can share a lot of this stuff. So for example, we've been recently trying to migrate a lot of our build systems across these platforms towards Bazel, because that allows us to actually share a bunch of the tooling and not have to build it across each of these platforms.
And would you say on the back end, right? We just our audience of Java developers, right? From just being Gradle, being the organizer of this event, do you see more Java than Go, or would that be like the one programming language that's predominantly used there?
I believe like we still have a lot more Go than Java.
Mhm.
However, we still use Gradle for some parts of the Monorepo development, mainly the dependency management, because that's something that we kind of like inherited over a period of time, and we kind of like use it to kind of resolve a lot of the dependencies. Bazel still has some paradigms that it wants us to follow, like having single version of a dependency in the Monorepo, but that does not really scale well for all types of use cases. So Gradle allows us to have like multiple versions of dependencies. So we still use some part of that. I would say Go is about twice the size of Java, but so that kind of mainly contributes like the backend. So Java is about 1/3, Go is about 2/3 roughly.
If we just wanted to contrast that with the number of mobile engineers, we'd say mobile engineering is about 15% of the overall engineering audience. I think we have close to 300 Android and 300 iOS engineers.
Wow, that's fairly huge. Justin, we got a question from the audience.
Yeah, Hari wants to understand about the org structure. The 150 engineers that you brought up supporting the dev productivity, are they just like solely supporting the dev productivity tools, or are they also involved in supporting infrastructure like the physical container infrastructure and that sort of thing?
We have a large infrastructure org the developer platform is part of. The org itself is probably well over 1,000 people. And there's a number of different sub-orgs within that, including like storage, bare metal, developer platform is a part of that. And there's a number of others. So that is the entire org that focuses on the infrastructure. And then, probably 2/3 of the company is focused on more of the product development, where we have orgs around like the writer, the driver, eats, freight, etc.
Very good point, right? A lot of folks are like, well, we got 500 people in infrastructure. I guess we're working. We got a big productivity team, and as to the point, that's if you want to ship software at the scale and at the speed of Uber, I mean, looking how fast Uber Eats and whatnot came out, right? That's what it takes, right? And that's why we're here to kind of share. There's no secret of how fast these organized at this size can go to market so fast, and that's super huge. Thanks for sharing that. That was great insight. One other topic I had here regarding well, before I get into that, actually, Gautam, I remember a long time ago when you were working on mobile only. Hans and I met a few folks. We had a few meetings at Uber, and there was even some Java stuff built with Maven there. Were you able to? Is all the Maven out now? Did you got it? It's so hard to standardize on a build system, but we're going to get into that topic in a moment. But is there any Maven builds left in that code base?
Yeah, I think it's a good question. I believe a while back the Java development was not as prevalent. So there were folks who were kind of experimenting with it, and Maven was kind of like the de facto standard at that time. There was some Gradle usage as well. What we did with standardization was brought all those micro repositories into a monorepo, and that allowed us to actually share the tooling and come up with like better standardization. Actually, when we brought them in initially, we were still using Gradle to kind of like make sense of the project before we started looking into other build systems. And I believe like Gradle came a long way since then in terms of scale, but back then it was still not scaling for like the number of modules that we had. So we started like picking off Maven slowly. So at this point, I don't believe there's any Maven usage, but there used to be maybe like 3-4 years ago, probably when the Monorepos were not fully formed yet.
Great segue to the next topic. Tell us a bit more about just tools and CI/CD and this standardization of build systems. Right, we're seeing it at some organizations. There's definitely folks on either side of this. It's kind of like, in a way, it's kind of like a monorepo, multi-repo conversation. Right, there's folks on each side. It's like, should we standardize? Should we not? It's a lot of it could be about the culture, the engineering kind of structure and talent, the tools, right? Tell us a bit about that and that effort and how you were, the challenges maybe even you faced and how you were able to kind of make it work.
So we have essentially 5 major monorepos that we support right now that we talked about: Go, Java, Android, iOS, web. Out of those, 3 are on Bazel today, and 2 are on Buck still, and in the middle of a migration towards Bazel. iOS and web and Go were able to kind of make that migration a bit earlier, and Java and Android are collaborating pretty closely to kind of do that migration from Buck to Bazel. For Android, we did, when we decided to make that move, it was over a year ago, we worked with the Gradle team. We did kind of a full evaluation of Gradle at the time. We did kind of have the discussion of, moving to the industry standard that's used externally within small companies, which is Gradle for Android development, versus converging with the rest of the company, which was on a strong path towards Bazel. And we had a 6-month-long kind of evaluation to kind of walk down that path before deciding, that we would be kind of investing heavily in converging on Bazel with the rest of the company. So at this point, like I said, there's 3 that are there. There's 2 that's on the way. And we see this as a prerequisite to an eventual mono repo, right? Like combining all of our repos. But once we're able to have standardized tooling and converge there, then we can start to gate a lot of developer efficiencies that right now might be more challenging, where we're having to build that tooling and infrastructure repo per repo.
Yeah, I think the other thing you asked was is like, how do we think about like topics like mono or micro repo, or like multiple micro repositories? I think at the scale that but we are currently operating, or even like imagine someone else working on like a lot of different services as they're approaching that scale. At some point, when your stack becomes like fragmented, you are not going to be getting the gains from the scale of you're not getting the efficiencies from scale, because you have too many kind of things to support, right? Because we have to think for each ecosystem, you have to keep things up to date. Think about like security upgrades, as well as like making sure that your developers are able to be productive in each of these stacks. What happens eventually is that it becomes difficult also for developers to move between stacks if you are having like a fragmented way of doing things. So it doesn't really matter much if it's a monorepo or microrepo, but the standardization has to happen either way. And I've seen like successful companies kind of adopt both models, but I think what they do really well is the tooling around it. I mean, I think Netflix and Amazon have like this microrepo approach. I believe like we do monorepos as well as Google and Facebook. And I believe in all of these scenarios, the tooling is actually what helps them to do things really well, and making sure that they have uniform tooling across the board. So like an iOS developer can probably go and code in Android, or like a backend Go developer can quickly go and make a change in Java without having to relearn and take a bunch of time onboarding. And that makes, I think, the efficiencies even better when you have like the same standard frameworks.
Awesome. Thanks for sharing. Justin, we have a question.
This one, because I've had a lot of people who are actually super interested in your use of Bazel around building Android applications. And so the general question is sort of, how big is the Android Bazel community to your knowledge? And is it a lot of work to maintain an Android built in Bazel versus building it with Gradle?
That's a great question. So it's definitely not an out-of-the-box experience right now, but the Android Bazel community is maturing very quickly, and we see a large number of our peer companies either already moving Android to Bazel or are seriously kind of investigating and figuring out what that plan looks like. At a certain scale, with a certain extensible infrastructure, it starts to make sense when you kind of have a team like ours that can really invest and build on the types of things there. There is an active community of third-party, tooling companies and resources for Bazel in general. And as a build system that's kind of more agnostic, it does set us up on that path towards an eventual monorepo. We do work very closely with our peer companies. So we are investing heavily in like the Kotlin rules and putting stuff upstream to Bazel core. We see a lot of maturity happening there with like AOSP moving over to Bazel, but there's still some work to go. And it wasn't just a drop-in replacement. Obviously, Gradle is the seamless experience for your small apps, right? But once you start to think about our scale and needing that fundamental investment in the infrastructure, it starts to be a very useful foundation that will enable us to kind of share those efficiencies in the organization and provide a better developer experience and a faster set of builds for the scale that we're dealing at, which is, I think Android is something like 10,000 modules. 10 million lines of code. I think we're probably one of the largest apps in the world. I think number 2 probably. What makes us different from Google or some of these other companies that maybe have more Android developers is we have a convergent architecture. So all of our apps are kind of built in the same way and are plug and play, and things can kind of move between all of those. And so once we have a lot of that, consistency, then it makes sense for the underlying build tools to also have that consistency, and we can start to gain those efficiencies not only within Android, but when an iOS developer comes in and it feels very consistent, or when a Go developer needs to stop in and it feels very consistent. And we are seeing those wins, right? I think our recent analysis had something like 30% of developers are polyglot developers and move between these different repos. So we're definitely seeing that as an advantage.
And I recall, just being in that part of that conversation and that evaluation with you guys, and performance-wise, we're able to do some stuff to get it up there, of course, but at your scale of modules, right? That's where the main pain point. But what was the final reason, right? That the big reason that, I know I just want everybody else to, for you to share with everybody that you were like, okay, hey, this is why we're going to go with Bazel.
Sure. It's definitely a number of them that add up. But, at the end of the day, one is the investable infrastructure that aligns with the rest of the company, right? And you don't want to necessarily staff a full DevX and build team per technology stack that a company is supporting. There becomes a lot of engineering waste. There are huge efficiencies we see where someone builds a Bazel optimization for Go or for Java, and we can immediately inherit those. And when the company is staffing dedicated CI infrastructure, build infrastructure, IDE infrastructure to support this scale, and then you're duplicating that with unique build stacks per repo or per tech stack people are working on, that's a lot of kind of wasted efficiency. So by converging and bringing that together, we're able to move our developer community that much faster because we have a lot more contributions in the infrastructure and the investment.
And basically, long story short, right, you have a team of 150 folks building custom developer productivity, developer experience tooling for Bazel. You can't be doing this for 3 or 4 or 5 different build systems. It just doesn't, you can't scale it. And that was ultimately like, hey, the whole company's going to Bazel. Let's standardize on one build system.
That's definitely one part. And then, they're obviously, having the some nice tools like remote build execution that we're looking at, or how it integrates with our CI. There's some other wins that we kind of pulled out, but at the end of the day, when you're thinking of a large engineering organization like that, convergence and consistency can help significantly in your developer productivity.
And before you get into Justin's question, and we got a commercial break coming up as well, I have one for Gautam. I've been meaning to ask you this, but I always forget. You guys migrated, well, at least the JVM stuff, to Buck first, to then migrate to. I was always wondering, and I never got to chat. Why not just go straight to Bazel? Why go to Buck first?
Yeah, it's an interesting question. I think it goes even before that. I believe a lot of the Maven repositories moved to the Maps Monorepo, which was actually written in Pants, which is another build system from Twitter. So we migrated from Pants to Gradle because we wrote a Gradle plugin that could migrate us to Buck. And eventually what it did was we basically wrote like our custom target rules all in so that we don't actually use the Buck rules directly, but abstract around it. Then we can actually swap. That's kind of what we're doing right now. We're swapping the implementation of the rule to use either Buck or Bazel. So the reason why we did this is also because we had some technology back then that would go from Gradle to Buck pretty quickly. We didn't have that for Bazel, and that was something that we didn't have the time to invest in. But we thought if we can get the efficiency wins right now, moving from Buck to Bazel is actually fairly easy because they are very alike in that some of the engineers that built Blaze back at Google back in the day were the ones who actually built Buck. So we kind of thought this strategy would serve us really well, and seems to have been good for just business continuity because we didn't want to stop the world to these migrations. Yeah. And doing these migrations in place is a whole other topic that could be talked
yes. We could go into that for forever and ever here. I'm going to ask you a kind of a contentious kind of question. With Facebook revamping Buck, I think they call it Buck 2 or whatever. I don't know. I'm not familiar with it. Why not stay on Buck? Well, migrations are so expensive. So why not just keep everybody on Buck? I mean, Android's already on Buck right now, right?
Yeah, that's an interesting question. I believe the state of development of Buck is still ongoing. I'm not sure what the release timelines look like for that. But also, it's not just a decision we can take localized. We have to think about the global picture. Like all the other frameworks and platforms have already moved on to Bazel, and there's a whole bunch of innovation happening there. Like the remote build execution and everything is already figured out. There is a lot of like community. There is a Bazel con. I don't see there's a Buck con yet, but maybe once Buck has its own conference, we'll have like a large enough community where we can actually share these things. That will allow us. And the good thing is we architected our stuff in such a way that if you wanted to try Buck V2 down the line, it's very easy to do so because implementation is not specific to Bazel. We can swap out stuff, as I just mentioned to you. Of course, there'll be some nuances, but we are kind of keeping the door open because there might be something like another foo build system that's probably much better than Bazel one day, and we want to try it because it probably won't scale. So we want to keep that door open based on our learnings from what we did in the past. So we kind of are architecting our systems in such a way as to not tie us too closely. But at the same time, I think the immediate wins are so obvious that we felt it's the right time to move towards it.
Folks, we have a quick commercial break from our sponsor. We thought you would enjoy this one. Let's kick that off.
Do you suffer from developer discomfort? Hello, I'm Dr. DPE. If you're one of the millions who suffer from double D, you know the soul-sucking misery of long build cycles, unhelpful error messages, searing abdominal cramps, and difficulty passing deadlines. You may be tempted to solve the problem with homemade remedies or over-the-counter supplements. No. If you're in the throes of developer discomfort, you need clinically proven, doctor-recommended Gradle Enterprise. With Gradle Enterprise, you'll get faster builds, easier debugging. You'll even remember why you chose software development as a career. Gradle Enterprise is recommended for the treatment of developer discomfort. Side effects include shorter build and test cycles, smaller change sets, whiter teeth, fresher breath, and the unbridled admiration of your peers. In clinical trials, some users reported no longer having time to call their moms while waiting for builds to complete. Ask your doctor, a real doctor, if Gradle Enterprise is right for you.
That was the kind of the key takeaway there. Really quickly, since we're on that topic, right? Not everybody has amazing talent, engineering talent that you all have, and that executive sponsorship to put 150 folks on developer productivity engine and have another infrastructure org, right, with like 1,000 folks or whatnot. How do you guys decide build versus buy, right? What should you build your own? What should you buy? And I get this might not be like an official stance from Uber, but in your all's opinion, and you've been to many large organizations, what do you think?
I can take a stab at this. So each build versus buy case is kind of we take it on a case by case analysis. They're with a large internal infrastructure. And a number of tools already with tight integration. Obviously, anything that we're looking to buy, we would want to have that type of integration. And so there'd be a lot of requirements that would come with that. I'll give an example from the mobile space. We have an internal crash reporting tool. A lot of people use, Firebase or Bugsnag or Sentry or any of these others, and they say, well, why do you build your own? And, at the end of the day, it's because of the really tight integration in the guaranteed SLAs and having the kind of the teams internally there that are able to do that. So that's like in that example, but not everything, we build internally. A lot of what we think about with kind of modernization and making developers productive is giving developers things that feel comfortable to them and give them transferable skills. So, there are areas where we are adopting third-party either libraries or services as well. As in the mobile world, we're frequently looking at the libraries coming out of Google or other Square, other third parties, and we're adopting those. But we also have a large amount of internal libraries and investment in infrastructure that we need that to integrate nicely with. And so even that integration layer, that plumbing layer, can be an expensive cost for an organization where they have to invest significantly in that. And so, I think taking it on each one of these cases and understanding those integration points, the support requirements, the cost of building it internally versus consuming it externally, all kind of fit into how you would think about making that decision.
Awesome. Thanks for sharing. Now to, kind of our favorite part of the conversation. We should probably maybe get into some of this stuff back. Tell us a bit about, measuring the impact of developer productivity and developer experience. What data are you looking at? What are your deliverables and metrics for success?
Yeah, I can probably take a quick stab at this. So we measure a lot of things when it comes to developer productivity. The general things that I think that come top of mind are things like the build times, obviously. We also look at things like the failure rates, specific tool performances like the IDEs, app performance as well. That's more towards like production and application performance. We also look at things like the developer throughput. Like we look at it at macro level, like, hey, if developers are productive, they should be able to like write more code effectively. It's just like a general indicator of understanding, is there something that's slowing people down without us knowing, right? So we also take a look at the macro picture. Even though builds could be fast, it could be that your time to like get your diff reviewed and like land like merged could take a really long time. So you kind of also like look at those things. I don't think I have everything listed here, but the things that are easier to measure, obviously things like CI/CD time. But we also look at like the qualitative stuff. So every quarter we run like a developer NPS survey where we ask them things like, hey, what's bothering you the most? Do you think the workflows that you're currently using are effective? If not, like, please tell us why. And we kind of collect that feedback and use that to drive our decisions as to where to invest and prioritize our work. So we deliver the best value. Going a little bit into like how we measure, there's a lot of different ways, but I think for a lot of our intelligence is powered through something we call like local developer analytics, just a tool that we wrote that's like a daemon that runs on like all the engineering laptops that collects information about like the build system failures, but also not just the direct build tools, but things like the Git CLI or like the code review CLIs. Right. You also take a look at like how much memory you might be using, or maybe you're on like a really old MacBook and you're due for a refresh. And that actually has some very interesting repercussions. Maybe Ty can talk about some of the stuff that we have done that based on acting on that data as well.
I'll add something to that kind of reflects one of the questions here about how do we measure that in IDEs. So we have the LDA pipeline that has a lot of entry points from different tools. We have the local daemon that runs on machines and on CI and on our remote dev servers. We also have IDE plugins that talk to that as well. So we built custom IntelliJ and VS Code plugins that funnel that data up, and so we get a lot of granular data coming out of that. We can see indexing time and code analysis time and UI freezes and time to open files and autocomplete, like tons and tons of data. And so we are actively, we work with JetBrains very closely as well on the JetBrains IntelliJ side, and then we work with the VS Code community as well to kind of make sure we're doing that properly. And then lately we've been thinking about how do we kind of converge to one aggregate metric that will represent that, so we can then have a one metric story that explains the developer experience when it comes to IDEs. And so what we've landed on is a term called aptex, which is kind of an industry standard way to aggregate time series metrics based on thresholds that are set that define a user's experience. And so we're able to take indexing time and UI phrases and a bunch of these and apply them as an aggregate metric for something that we can then track and say developers are having a good experience, they're not having a good experience, and then we can cross-reference that with like Gautam had said, we can see, the developers on the older laptops are having a much worse experience, or developers on this version of Git are having, a significant degradation versus this newer version of Git that brings in the new file watcher. So we can start to make a lot of, bring a lot of insights from that data that allow us to prioritize and make decisions for what we invest in.
So you need to build the tools to basically build and maintain these things that, one, collect the data from all these different places, then put it into one place, and then another set of tools to actually make sense and make it actionable and easy for your team and Gautam's team to review and say, all right, folks, we got to prioritize X, Y, and Z based on kind of this data.
And we have to contrast that with the developer's input directly, right? You can't just rely on metrics for what is an experience? What is a subjective thing? So we take in both the kind of the narrative and the feedback from developers doing like, developer UX studies and NPS surveys, and then cross-reference that to the data. And then obviously we have a lot of domain experts that we hire, and we pay good money for their skills, right? So we want to take that input into how to interpret that data.
Before we wrap up on metrics, and thanks for that, Ty and Gautam, anything else you want to add for metrics before we take a question there? It seems like Justin's got a bunch of juicy stuff from the audience.
Just see the questions, I think, to be more useful for the audience.
Yeah, thanks. We have so many questions coming in. And just a reminder that if you haven't seen the Slack link to join our community Slack, we will be having a follow-up discussion in there. So please join us if we don't get to your question. This one should be pretty quick. People want to know which IDEs are actually in use at Uber and how specifically the Bazel integration is working with those IDEs.
Yeah, I believe the two things that Ty mentioned were like the JetBrains IDEs as well as the VS Code. So all the platforms except iOS, so the iOS is a kind of special case where they use Xcode primarily local development. But most of the platforms that we use currently have support for either VS Code or IntelliJ or flavor of IntelliJ like Golang or WebStorm. And those are the primary ones. Of course, like, developers can use other IDEs or editors. We technically support these IDEs primarily, and we create plugins for them. And like as I mentioned, like we have pipelines to collect analytics from these, so we're able to act much quicker when issues do occur. I don't know if that answers like the question or if there's more detail, but generally speaking, like we're trying to keep it like a small list because even though the size of the team it might look like a lot, but it takes a lot of effort to like really understand and invest in these IDE ecosystems, especially things like JetBrains, where not everything is like open source. Some of the stuff that we use from like the Golang and the IntelliJ like enterprise editions are not fully open source. So we have to like maintain a constant relationship with them to kind of like relay what's happening on our side so we can get like some resolutions done. So it takes a lot of effort to like do this. So we try to keep it scoped to like a couple of them as much as possible.
And great segue into the next kind of topic, one of the more exciting ones for me, at least. Right now, you got the data, you have the tools. And so what are some of the interesting wins that you can share that you guys had in the last few years or whatnot?
I can talk about a couple, and then I'll hand it off to Gautam to talk about a couple. So one big project that we've had going on for a little while now is a heavy investment in remote development servers called DevPods internally. And that essentially allows us to provision these remote machines that are, fully ready to go, that, we can check out the repo, we can put all of the like IDE indices in place, we can have the IDE running as a daemon, we can have it all ready to go and available to the developer. And so, seeing that data and saying, hey, these local laptops are limited in performance because we have these giant monorepos that need to be built. Especially on mobile, we have, we're building orders of magnitude more because you're trying to assemble, monolith apps, essentially. We're in a backend world, you're building little microservices. So you're doing a lot of heavy compute work, right? Your memory, CPU, IO, and, most developer provisioned laptops are not set up, to be able to do that. So by putting this all to the cloud, we have been able to give a lot more compute resource to that. And, we took that as one. And then another one that kind of sits nicely into that is we've recently been upgrading all of our mobile engineers to start, but we'll start with the backend engineers to the new Apple Silicon laptops. With that data, we were able to see that, there was an order of magnitude increase in the performance going from the old Intel chips that were on the Mac developer or the Intel developer laptops to Apple Silicon. And so that allowed us to then put a proposal out to early upgrade a bunch of folks and then push really heavily to make that a thing.
Cool. I think to add a little bit more info on that one, I believe some of the other stuff that we collect in the IDEs, for example, things like what files are open, what actions are being executed, was very interesting for us to like do some really cool optimizations to the IDE in terms of like lazy loading projects. So we started looking at like modules that take a really long time to index. We could actually then give this data back to the teams and tell them, hey, if you break this module down, you would have much better experience working with IDE because the indexing will be much faster. And the same way, I believe on the CI side of things on our backend, we noticed, for example, like a lot of our tests were flaky. So when we collected data about flaky tests, we built systems to automatically tag them and make sure they're quarantined and let the developers know that these are flaky tests. So this is very important at our scale because when you have tens of thousands of commits happening, you do not want these things slowing you down when you're trying to actually merge your changes. So this kind of has like a good effect for us because we also measure like what's the rate of failure for changes that are coming in where the developer is not at fault. And we were able to drive that down significantly. That led to like really good improvement in like developer satisfaction. I believe there's a slide that we can show like some, for example, we started a lot of this work back in 2017 where the developers were not actually like fully satisfied with our environment. And this is like across all the different like platforms. And we kind of like chipped away at some of the main things that they're concerned on. And this is kind of the NPS progress that we made. And we're pretty proud of where we are from compared to like where we were maybe like 5 years ago or something like that. So it does take a really long time if you're working at this scale to like get to that state. But I think some of the other stuff, if you can get a chance to talk about that we're thinking for the next few years, would also be interesting to kind of bring that number up higher as well.
A couple more minutes maybe on this topic. Ty, you tell me about your, I don't know, we were having drinks or having dinner somewhere, your what you guys did with the whole diff pipeline and whatnot. What can you share? That was a very interesting win that I thought audience could enjoy and benefit from.
Sure. I could talk a little bit about this. So one of the things I think someone asked also previously in the questions, like how do we make sure that when so many comments are coming in, that people are not stepping on each other and we're able to keep the state of the code base like healthy? So one of the things that I think we wrote about this previously, that we have as a gating function is something called submit queue, where changes come in to get verified before they get merged. This is very good because when you are opening a change against like a base revision, a lot of things can change from your peers that you're not aware of. So while you're making your changes, maybe by the time you're able to like merge it, something else might have broken. So submit is kind of like good for the safety aspect. But as you can imagine, there's a lot of changes that come in. So the safety aspect is great, but then latency can get worse because you're waiting for all these changes to merge. So what we did was we kind of took like an interesting approach. We already have build systems that support like remote caching and stuff, but we went a little step further and said, for each of these things that we need to build, we really only need to know, like have like a bit that says, is it like fresh enough, right? So we don't have to actually download the build result to know if it's like already built or not. So we built something called validated targets, which is like for each build target, we kind of store like a bit that says that, hey, on this change that you made, these tests passed and like maybe like these targets built, and we send that really quickly. So when you, let's say, update the change and you're doing an incremental change on top of that, we are able to query the build system quickly for these targets, like metadata, like a hash, and quickly say that, hey, you don't need to go build this stuff. You only need to build a very small subset, right? So, and this is good because anytime someone's doing this, like just on their particular like change set, while they're actually merging, a lot of this information can also be reused. So it really helped in cutting down our latency from, I think, like a couple of hours at some point, which is pretty bad, like less than 15 minutes. And we haven't continued to iterate, for example, on this. But the recent thing that we did was we noticed that a lot of changes usually hang around before they go and merge back because maybe they're doing some reviews or testing. But what happens is if you're steering way far from like the main branch, by the time you're able to merge, a lot of things have changed. We have to retest a bunch of things to make sure it's safe. So what we are doing in the background is every few hours, we rebase you on top of main and run these checks and cache the results. So when you decide to actually merge, you're not too far off from it. We actually already have these results. So we're able to keep you like kind of closer to the cache because we have the capacity, so we're trying to use it more efficiently. So there are some very interesting stuff that we tend to do to kind of keep the train, like the build trains and everything going very smoothly.
Awesome. Thanks for sharing that. We have two more topics we want to get to and do some Q&A. Tight timeline here. I want to get into I was very fascinated by this. Your remote cloud IDEs project, right? I don't know what the actual official name. It's very interesting because that discussion has been happening a lot here, at my company with on the Gradle Enterprise front, on the Gradle Build Tool front, should we invest in remote builds, especially now that M1s are fairly fast, right? You're getting different data back from the industry. I mean, we invested in test distributor. We saw there was a lot of stuff with most of the pipeline is around tests. But I think there's a lot of misconception with remote builds and actual remote cloud IDEs, and it was really interesting when you were explaining it to me, Ty, and I thought our audience would get a big kick out of this.
Sure, I can take a stab at this question. So starting a couple of years ago, we had just general remote development servers that people would grab an AWS box or something and use that just to do a big build. And we started to put a team together with VS Code over SSH when that came out. And for some of the developers that like using VS Code or like the non-JVM projects, like that made sense, and people used that and enjoyed it. And it was an upgrade from building on their local laptop. But a bit over a year ago, JetBrains introduced an open source tool called Projector, which is kind of a way of just rendering the IntelliJ UI over the internet. And it was a better experience than what you get with like traditional screen sharing from a server like VNC or X2Go or any of these. And because we were having these really big problems with Android build times, because we have these massive monolith build graphs that need to be built, I started prototyping a solution on our DevPod is the name of the product, using Projector for Android developers, and then forwarding ADB to the server to do talk to the emulator and that sort of thing. And it just really took off because people were seeing this as a huge step forward in their productivity, even though it wasn't. It took a lot of manual work at the time. So we started investing and we kind of saw that opportunity. We started working with JetBrains on their gateway solution, which is kind of their productionized product version of that, which is a mix of Projector and the Code with Me. So it kind of gives you a faster feel when you're doing that with a native thin client. And we invested there to give kind of standardized support for all of our Monorepo. So we have these images that people check out that live on GCP, and they have a fully ready-to-go developer environment for the different Monorepos. You can get the Android flavor or the Java flavor or the Go flavor, and it's going to have the IDE set with all the plugins, installed with proper VM options. We generate the indices to disk, and we preload those in, and we're doing that nightly as a snapshot. The IDE is running as a daemon, so as soon as the machine boots up, or they create a new one, it's just ready to go. The Monorepo is checked out, it's fully indexed. And then, when they're doing their builds there, it's also doing the builds on these really beefy, cloud servers. And so that's typically a much better experience as well. And so that's a little bit different from, just remote build execution, where you're still doing it all locally and then you're just kicking off your builds to distributed machines. But what we've seen is it's not just the builds that people are having issues with. It's also the IDE performance, and dealing with these giant monorepos can be really bad. And we hear that a lot in our NPS, and we see this in our metrics, that when you're indexing millions and millions of files, the IDE is going to slow down, and you're going to have UI freezes, and a lot of that does become improved when you're putting that on a dev server as well. So part of it is the performance, and then part of it is we have these managed environments. The developer doesn't have to do anything. They type one command on their CLI and they have an environment ready to go. And that is huge when, you think traditionally a developer has to always be upgrading versions of things or installing new versions of their IDE or upgrading Mac OS or Linux or Windows, and kind of doing that and running into the developer pain of setting things up. And we take all of that away.
Failures caused by different versions of Java, just little stuff, right? And it's really interesting, right? Because folks think, oh, well, remote builds is all about faster builds. Well, especially folks coming from Google and Facebook that have this type of tooling built into the build system and the IDs and whatnot, right? And it's not a trivial thing to do. I mean, maybe you don't want to, this must have been a really big effort, right? To do something like this, right?
Yeah, it was a multi-year effort, building multiple teams. They got incremental staffing and got, as the adoption increased, we've invested further. We've been working closely with third-party companies as well to kind of evaluate, work with JetBrains. We evaluated some, third-party products like Gitpod or Coder as well that kind of does some of this in the space. So it's been a large collaborative effort to get us where we are today.
Want to get to this, as we wrap up, you've built some amazing tools. You've done some really cool stuff to improve developer experience and developer productivity. What's next for you guys? What's your moonshot when it comes to, what's your DPE moonshot?
Yeah, I think that's a good question. I believe we have some sort of strategy for that. The way we think about it is like, if we provide like really modern tools all the time and make sure the frameworks are always like powerful and up to date, and make sure that there are safety rails when you're making changes to guard quality, and we're doing it in a standard way as much as possible to be efficient. I mean, this sounds like a very difficult thing to pull off, because it's almost like a pyramid where you call like a triangle where you can have two things but you can't have the other one. But I think that it is possible when you invest in the right technology. Our moonshot would be like investing into these kind of like, I think one of the things that I mentioned, like the remote environments. So there's some really cool stuff we can do with them. Things like, for example, you could spin up a new environment pretty quickly, and you could pair with a colleague to do like a code review, or you could give your environment to them and say, hey, go test my change locally and tell me what's going on, right? Great for prototyping, and makes it very cheap to do so. And eventually, like, let's just make like build time not a thing anymore. Like if you look at some of the other languages like JavaScript, like they did have like instant builds where you quickly make a change, you're able to see what's going on. So investing into things like server-driven UI frameworks, obviously, which are pretty popular in the mobile world, but also like what are ways we can do like dynamic class loading when you make a change? Like there are like some technologies that I believe like JRebel and others that have kind of invested in these things in the past for Java. But there are like a lot of these like cool things that we can do to kind of make the main pain points completely go away. And then we can actually focus on the real parts about building the features or improving the business, rather than focusing on all the other frustrating parts. I think that's kind of the DPE moonshot. But I don't know, Ty, if you wanted to add anything else on top.
Yeah, I think I'd add one for our remote development solution. I think is pretty interesting. So the vision I see there is that just like someone sets up a branch when they're going to work on a feature, that we have ephemeral dev pods that live for the life of a feature. The developer, would spin up a dedicated machine and it's fully ready to go and to work on their feature. They put it up for code review, and that's fully integrated into the code review system. So they can then context switch away. They can have a second machine or a third machine for other features or branches that they're working on. And when they get code review feedback and they need to go back to it, that machine's still ready to go, and their environment is hot and on that branch, and it's fully set up with the caches. So they can just click that from the IDE and be right back in looking at feedback or addressing your code review. And then when that goes to the CI and the CD system, we're also giving integration there, so that if there's a CI failure or a test failure, they can then step into debugging or exploring that directly in a live environment in that server as well. And we can have these ephemeral, feature-based dev servers that live from the beginning of it to when it lands on main, and then that takes away all of the context switching cost that developers would have that eats so much of their time today.
Awesome. Thanks for sharing that. We're towards the end. Let's take a couple of quick questions. We can, jump into and close it out, and maybe take the rest of the questions on the developer productivity channel and the Gradle community Slack. And Justin, maybe even throw that link in there. We do have a nice thank you slide from the Uber folks. Before we get into the Q&A, I want to thank, of course, Uber Engineering for allowing Ty and Gautam to come here and spend this time with us and share everything. There's you guys. We can go on for hours, right? We would have just spent like 30 minutes on build migration. Our audience would love to hear what you have to say about that, Gautam. But maybe we save that for the Develop Productivity Engineering Summit, which is coming in November. I had to do a little plug there for that event. We'll have Dr. DP running around with this stethoscope and checking your laptops, fans, and whatnot. But let's take a few questions, and we can go on to the Slack for more. Let's take two good ones.
Yeah, I think I'm going to collapse these because there's a number of people who are really curious about the M1 Mac experience. So first of all, if you could give us just a general idea of how productivity trended kind of at scale as you moved folks over to M1s, And then also, kind of a second bit of that question, what kind of friction did you experience? For instance, some people are mentioning that when they moved over to an M1, it broke some of their, the architecture change broke some of the testing that they were dealing with. Did you encounter any of that? Do you have kind of repeatable solutions that you could recommend?
Sure. So at this point, we have upgraded all of our iOS community and a large chunk of our Android community, and we're kind of in the earlier stages for upgrading Java and Go and web developers. iOS, it's all using the Apple toolchain typically, so that there were some Bazel changes they had to make, but that was pretty straightforward. For Android, there were a number of changes that needed to be made in relation to upgrading like JNA and JNI focused things in the build system, or specific libraries in like the testing environment, like Roboelectric, or like even we had to migrate our version of Gradle to support, like, because we use that for dependency management, even though we're in Buck. So there were a bunch of one-off stuff, and we invested in that within the organization to solve that for developers before we pushed widely on that push for folks. I think we also worked with we have a client like engineering team that works on, it's like more like IT, and there's a lot of stuff that's provisioned via Chef. We also worked closely with them to identify which binaries were having problems and managed and get those upgraded. So it was definitely across organizational collaboration to get that done. There was friction, but I think at this point we're seeing that at least for the upgrades so far, it's a pretty mature and seamless experience. As it relates to the productivity wins, we did see pretty significant build time and tooling performance time improvements, close to 2 to 3x over the machines we were provisioning before, which brings it in line for build speed with kind of what we're seeing out of our remote cloud IDE solution as well. They're pretty on par at this point. The cloud IDEs are a bit better with some of the changes we're doing, but it kind of brings it up there. And so the way we view that is by giving developers multiple tools, they have multiple tools in their tool belt, and then they can be as efficient as possible. They can have one branch on their local N1 that they're working off offline, and then they can have 2 or 3 different dev servers that they're using for different branches that they're working on, and they're going to get similar performance profiles and productivity out of all of this.
Oh, that's great. Thanks. Yeah, and then the 2 to 3x. That's really impressive. And then there's several questions too. People are curious about your test quarantine process, so I'll try to combine these as well. First of all, what's kind of your general criteria for quarantining a test? Is it like a flakiness threshold or something like that? And then how do you deal with if you have to test something that's along the critical path of the application, but the test has been quarantined? How do you manage that situation?
Yeah, that's a good question. So I believe the first one is definitely a threshold. The way we do this is we have periodic like CI pipelines that run tests, as many tests as we can in as many times as they can. And we look for tests that should not have failed because they already passed before they came into the main branch. The way we do quarantining kind of evolved over the years. So we used to be able to like add ignore annotations or something like that in code, but that would add cost because that change would have to go in. It would block other things from happening. And also, it was not as flexible. So what we do now is we have like a service that keeps track of all the different tests. So we kind of have like a history of where this test has been. Like it's been green for a while, it started being flaky, and then maybe someone went and fixed it, became green again. So this is also interesting because we also want to see like how tests move in and out to make other decisions down the line as to like what's the best strategy to like deal with them. The way we do it today is essentially we look at these tests, we kind of keep like a list of tests that are supposed to be quarantined, and we also created a ticket for the teams that says, hey, this is disabled, that reduces your coverage by X%, right? So you probably want to go fix that ASAP. And teams are pretty good about being held accountable to the coverage numbers. Usually, since the teams do understand, hey, it's critical tests are not critical, they're able to act on it. But there are cases where they won't obviously like act on it immediately. So what we also do is like we also run these flaky tests in another pipeline that's essentially also always running, but it does not block CI. So what happens is like, if, for example, there is a failure, you still get a stack trace back on CI, and then you can make a decision as a team, hey, is that because of flakiness or is it an actual error? So the flaky test can still provide a signal. So we don't want to be someone that just completely turns them off. So we still run them for signal, but we don't block on it. So that way we kind of get the best of both worlds till it's actually fit.
Justin, I think we got to say our goodbyes and start moving the conversation to the Gradle community Slack. Folks, moral of the story is here, right? If you want to ship software at a go-to-market at the rate and at the speed that Uber does, you have to invest in developer productivity. And that doesn't mean having a developer infrastructure team that manages your just keeps your CI servers and whatnot up, right? It's more than that. And you have to invest in developer experience and build the tools. And thanks for sharing a lot of that, Ty and Gautam. I hope our audience got some great inspiration from you, right, to do more there. And thanks again for joining. And thank you, Justin. Thanks again, Ty and Gautam and Uber Engineering for allowing you to come in. And we'll see you all next time.